All right. First question we got. I think I got 4 to go over. Let's see, 5-1, 37, 9-1, 55, 9-1, 75. Okay, they're in order, so we'll just go over the first one. First one I got is 9-1, 55, number 28. So, number 28 online. Okay, find the complementary angle of 36 and 1/4 degrees. So what does complementary mean? Means that both angles equal what? So you've got, you can draw a picture right here. There's 90 degrees. And one angle is what? This angle is 36.25 degrees. So they want to know what this angle is right here. So x plus 36.25 is equal to 90. And x is equal to, how do you get rid of adding 36.25? Subtract it. And that's right. So what does that come out to be? Well, 0.75 will be your answer. And then what's 90 minus 36 will be what? 50 what? 3? Because you got to borrow, so 53.75 degrees or 53 3/4 degrees. That should be your answer. Well, I guess it's not going to let me. There we go. And 3/4. Yep. That's how you do that one. Aprende? Any questions? Yeah, Hubert. No, Hubert. Thank you. 37. This is 9.1. 37. Now this one I told you is like a puzzle. And you can't blow it up, so what I'm going to do is I'm going to blow it up a little bit bigger so you can see it. So we got a line going this way. We got a line going this way. And we got a line going this way that is parallel to this line. And we know that this is angle 1, this is angle 2, this is angle 3, 8, sorry, 7, this is angle 3, angle 4, angle 6, and angle 5. Now, if these two lines are parallel, and I'm going to put a parallel symbol there and a parallel symbol here, because it says M is parallel to what? N. So are they the same line, only different locations? Yes, these are the same lines. The only angle they give us is the fourth angle, which is 100 and what? 128 degrees. So, right quick, what did I tell you about vertical angles?
They're equal.
So what's 6?
128 degrees.
Exactly. So 6 is 128 degrees. And what else is 128 degrees? Two and eight.
2 and 8, probably.
Yep. Now somebody tell me why 2 and 8 are 128 degrees. Because these two lines are what?
Parallel.
So they're the same line. So if they intersect this line here and make 128 degrees, and this is the same line, what does it make right here? 128 degrees. All right, somebody tell me what angle 5 or angle 3 is. What's angle 3 right here?
Probably. I'd say it's 62 degrees.
Where'd you get that? Well, this line right here makes what kind of a line?
Straight line.
Which is how many degrees? What's a straight line? 180 degrees. So if you've got 180 degrees, and part of it is 128, then what are you going to do to find the part that you don't know?
Add, subtract 180 from
180
128.
minus 128, and that's going to equal what, 60 or 52? And if that angle is 52, what is angle 5?
52 also.
And what are these two angles?
52.
And 52. And you're done. So you can answer all the angles now if they ask you that. I don't know if they'll ask you that or not, but.
They had one that had 12 on it.
Well, angle 6. They're asking for angle 6. Angle 6 is 128. I don't know why I can't type today. Angle 2 is 128. Angle 8 is 128. Angle 5 is 52. Angle 3, 52. And 52. And 52. Question on that one? All right, let's try nerd. This one is 9.26531. So this is 9.2, number 31 online. Determine the lengths of the given side for the congruent quadrilateral ABCD and A prime, B prime, C prime, D prime. In other words, you got, turn this over, flip it over, because this one is the same as this one. It looks like, I can't tell. It looks like to me, these are similar sides, similar triangles. And that's what you're going to call them, similar shapes. So the first one is A, B, C, and D. And it looks like that. Oops, well, you get the point. Something like that. A, B, C, and D. And this is 20 to 20 whatever units. This is 11 units. This is 71 degrees. And this is 134 degrees. I'm going to turn this one over. Why am I going to turn it over? Because it looks like this, only is smaller. Flip it over, this is what? A prime, this is what? B prime, this is C prime, and B prime. And they give us A for DA. So DA, I don't have it, this is C. Yeah, this is C. Yeah, C and D. My bad. C prime and D. Or you could just put it in the same order: A, B, C, and D. They're going clockwise: A prime, B prime, C prime, D prime. Prime means nothing mathematically. It means another box, basically. This is box. This is your first box. This is your second box. They give us DA, which is A, and give us at an angle of 52 degrees on angle C here. And they want you to find line AB. A prime, B prime. So they want this line right here. Well, you're going to use similar shapes is what you're going to use. Now, the only thing with similar shapes is you have to be consistent. You have to be consistent. Whatever you do on one side, you do on the other. You don't mix things up. You don't pick A from one side and pick C from the other side. What you do is you line up what you have. Now, I'm looking to see what we have. I don't see, let's see, AD, we don't have that right there. But we've got this right here, but we don't have this. And then we have this, but we don't have this. And they are congruent. We don't know the law of cosines and the law of sines because we haven't had trig. So we're going to have to use some kind of similar triangles or similar angles. Mine would be got one problem. 11 is to 20. 11 is to 20. Yeah. 11 is to 20. No, that wouldn't work. That 8 needs to be on this side. Let me turn it back around. Yeah, that's right. You'll have to bear with me a minute because this one's a little bit funky. Because they don't give us these two. We have to have one of these right here. They don't give us. Let me make sure I wrote it down right. The reason I'm going to write it down, I'm going to hit this button right here. I'm going to make sure that I've got it turned around right because that's what they're going to say do. They should say turn it around. Oh, how do I get rid of this? Let's see. Corresponding angles have the same measure, corresponding blah, blah, blah. To find the length of AB, find the length of its corresponding side, which is quadrilateral ABCD corresponds to AB in the quadrilateral A prime, B prime, blah, blah, blah. So AB is A prime, B prime. So that would be AB. And what they're doing is they're trying to get you to match up the sides or flip it over like I did. I flipped it over. But they're not going to flip it over. They're just asking you to match up the sides. Now use the figure to determine the length of side AB. The length of AB is 11. That's it. They're assuming then, okay, this is where I got a problem because it says congruent quadrilaterals. Congruent, if you look up congruent, that means that two sides are the same, or that means that there are similar triangles. So AB would be 11. Okay, that's what they're going on. Okay, they had to have something to go by because usually what they do is they give you this side. Let me turn it back around. Usually they give you these two sides or one of these sides and two of these and you set it up like a similar triangle. But here the word congruent, that word right there, if you look that word up, it basically says very similar. So AB is 11 and AB is 11. So you got to put that in there. Now that we've got one of these distances, we know that it will work out. So AB 11 is to 20 as 11 is to 20. So that means that this angle, this distance right here is going to be 20. In DC, we don't have that distance because they don't give us that distance. We'll have to figure that distance as 11 is to 20. No, we don't have that. We can't find that distance unless we use trig. So the congruent means same. This is not the problem I thought it was. The problem I thought it was similar where you set a side equal to x, you set a side equal, but they're just asking you for congruency. That means the same. 11 is to 11 and 20 is to 20. I don't like that question. And the reason I don't like it is because it's assuming too much. If I give you one, it's going to be similar triangles. Okay? So let's do this one. What's the length of A prime, B prime if AB is 7? 7. That's it. Let's do another one. What is AB if AB is 14? 14. The question is so easy, it's difficult. Because I was doing similar triangles. I wasn't even setting it up to be easy because I thought what I thought it was. So if AB is 16, what is A prime, B prime? 16. So that one is so simple that it's difficult. I wouldn't worry about it because that's not one I would give you on the test because it's too tricky. It's tricky because it's so easy. 9.320/8. This is number 8 in the homework. All right, Pythagorean theorem. Now, first of all, we're going to talk about how to pronounce it because there's nothing worse than someone trying to pronounce Pythagorean because the first couple of times it's cute. After that, it's kind of, you need to learn how to pronounce it because it isn't cute after about the third or fourth time. So, Pythagorean theorem. All right, Pythagorean. I want to make sure everybody can pronounce that. Pythagorean. I think everybody can pronounce that. Pythag. That sounds like a couple of words. O, like jack-o'-lantern, jack-o'-rean, and rean, like the second two syllables of Korean. Okay? Korean, rean. So, Pythagorean. So you should be able to pronounce that. Like I say, the first couple of times, it's kind of like, remember when VCRs first came out or CD players first came out, you always had the old people that said, oh, I don't even know how to turn my VCR on. Well, after about the first couple of years, that got to be old. All right? So, Pythagorean. And what is the Pythagorean theorem? It is a squared plus b squared is equal to c squared. Which means that on a right triangle, the sum of the squares of the legs is equal to the of the legs is equal to the square root of the hypotenuse. Okay? Now the legs, it doesn't matter because this is what? What is that symbol right there designate? Addition. And addition is commutative. What does commutative mean? 2 plus 3 is the same as what? 3 plus 2. So it doesn't matter which leg you call A or which leg you call B. It doesn't matter. Only thing that matters is if you know how to solve for C. That's what matters, or if you know how to solve for B. And we did that back in formulas, solving for a variable. So all you have to remember for the Pythagorean theorem is this right here. A squared plus b squared is equal to c squared. The hypotenuse, let's talk about that so you won't sound ignorant on it. Pot in use. Now some of you potheads, which I don't really want to talk about, that's what you might want to think about. Hypot in use. And that's how you say it. I would rather you say it like that than, I don't know what it's called. The hypothesis. And you do that. I don't like that. That's like, you remember when computers first came out? And people would say, okay, well, everybody uses those computers, but I don't like them, and I don't, like I say, after the first couple of years, that was okay. But, now everybody needs to learn how to use them. You need to know how to pronounce it. Hypotenuse. 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 That's how it's pronounced. Pythagorean. Pythagorean. Now, one thing about the hypotenuse is it's always the longest side. Write that down. It's always the longest side. So if you come up with an answer of 8 and your two legs are 10 and 12, then you know what? You're wrong. You've done something wrong. So let's look at this problem that was sent. This problem, we've got A is A, B is 5, and C is what? $13. That's right. So we've got to plug everything in. A squared plus 5 squared is equal to 13 squared. Plug and what? Plug and chug. Take the calculators out and see what you come up with. There's nothing worse than an old Sprite except an old Cheerwine. You ever had an old Cheerwine? Tastes like cough syrup. All right, so what is 5 squared?
25.
And what is 13 squared? 169. So a squared plus 25 is equal to 169. So write that down. A squared plus 25 is equal to 169. Now let's subtract 25. Subtract 25. And that'll give us a squared is equal to 144. 9 minus 5 is 4. 16 minus 2 is 14. Now how do you undo a square root? I'm sorry, I just told you. How do you undo a square? To undo, and I better put that in parentheses because somebody will say that's not proper. To undo a square, dot, 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 you take the square root. On both what? On both sides. So to undo this square, to undo that square, I got to take the square root of both sides. So I take the handy dandy red marker, and I take and I get A is equal to, what's the square root of 144? 12. Is that something that you should know? Yeah, because it's a perfect square. You know your multiplication tables. You should know your perfect squares up to 15, which is, we'll just go from 10. 10 times 10 is 100. 11 times 11 is 121. 13 times 13 is 169. 14 times 14 is 196. And 15 times 15 is what? 225. So you should know those. Let's do a nerd. Because I haven't went over Pythagorean, so we'll just consider that part of the class today. And we'll go over it. Okay, so let me get out of that and we'll go over some of those. That's all the questions I got for homework, so I'm going to move into something else now. I can't even... Why don't I just quit today? What do y'all think? Well, see, if y'all interact, if I say, well, I'm going to call off class or quit, y'all will say, okay, I'll talk to you then. I don't understand what I've done to y'all. Y'all talked to me for 5 seconds when I come in, and now y'all won't talk to me. Mr. Lassiter, did that help?
Yes, it did.
Okay, we're going to do some more so I can discourage you. Right?
Probably so.
Yeah, see, she's discouraged, mad, and leaving. I don't blame you. I get mad and leave too. 9 point what was that last one we did? 9.2?
Yeah. Do another one on those shades.
I am. I'm going to do one on each one that we did. There's one. We got to do one of those, but I'm not doing those yet. I don't want to get the cart before the horse. And what does that mean? That's the one I thought we were doing right there, similar triangles. You'll get one of those on the test for sure. I was trying to find the Pythagorean theorem, so just hold on. Must be in an early chapter, or early of the section. It is. That's all right. We'll go back to the beginning. See if it's in here somewhere. Okay, I guess not. Well, hold on. What chapter is this? 9?
Mm-hmm.
I would say it's in here. But I may be wrong. Look at there. I tell you what. There's a Pythagorean theorem, so it's in 6.9.3. That's why I can't find it. It's in 9.3. See, another one getting discouraged and leave. I don't know how to keep y'all from leaving. Y'all just keep getting discouraged and leave. Well, I know they teach it. It's in here somewhere. Y'all ain't gonna tell me, so. Okay,
It wasn't in there much.
it's not in there.
Wasn't in there much, it was.
Well, that's all right. I'll find it. Just hold on. I'll just go in the book and find it. So I'll just find it right here. I'm not going to do a moat because last time I checked, we hadn't done too much moat crossing in the last few years. So we're going to move to something else. Let me just go to the homework in the book. There we go. All right. There's 4 problems right there. We're going to do all 4 of them. That way you'll have 4 to do in your homework. .3 is in the book. 20 or 19 through 22 right there. So work on those for a second, or a minute, or an hour and a half. Hmm? 19 is C is the hypotenuse, 15 yards and 8 yards. And yes, you will need a calculator, because some of these, you know, will have some big numbers. And you need to be able to take the square root of a big number with your calculator. And they say I'm loud. All right. We'll just work them over there on the side. The first one says 8 yards. And I don't really care about the units. You can write those in the answer. And X. So that's going to be 8 squared plus 15 squared is equal to X squared. And that's 64 plus 15 squared is 225 equal to X squared. And 6, 8, what is that, 289? Now, take the square root of both sides. Well, some of you may not know how to do the square root in your calculator. So that would be 289. The easiest way is to punch in 289 and then the caret symbol or the X to the Y key or the Y to the X key, whichever you have, and then 0.5. That's the easiest way to do it. Now you might have a square root symbol and that's fine. I don't use the square root symbol because this is easy. You type in 289 and then you hit caret symbol 0.5 and then you hit enter. Somebody do that, tell me what you get. How much? 17 is your answer. So 17. Now, is it the longest side? Yes. So that's how you do that one. So now let's do number 20. Number 20. X on the bottom, 12 on the side, and 15 on the side. So this one is going to look like X squared plus 12 squared is equal to 15 squared. Plug and chug. X squared plus 144 is equal to 225. How do you get rid of adding 144? Excuse me. I get x squared is equal to 81. And what's the square root of 81? 9. That's right. All right, let's go ahead and do this one. Number 21. Oops. It says I've got a triangle on the side, and it looks like what? 5 and 6? No, 5 and 13. So we got 5 here, 13 here, and x here. And that's going to be x squared plus 5 squared is equal to 13 squared. X squared plus 25 is equal to 169. How do you get rid of adding 25? And that's going to be x is equal to what? 144. And take the square root. What is x equal to? 12. So x is equal to 12. All right, let's try another one. And the last one, I'm going to flip it over because nobody looks at a triangle like that. So I'm going to flip it over and make it look like this. And the bottom is 10. And the side that has the square, the two squares that give you the legs, is 24. So 10 squared plus 24 squared is equal to x squared. We're looking for x. And 100 plus 24 squared is what? 288 is equal to x squared. 388 is equal to x squared. Take the square root of both sides. X is equal to what? It was? What's 24 squared?
24 squared is 576.
576. Well, y'all should have said something. 576.
Yeah.
So that will be 676 is equal to x squared. Take the square root. Raise 676 to the 0.5 power. What do you get? I'm sorry. I didn't hear you.
Square root 676.
26. So your hypotenuse is 26. And that's how you do those four problems. Now, we haven't talked about the circle. Let's talk about the circle. Because it has two formulas you hardly ever used. The perimeter and the circumference. I mean, the circumference is the perimeter and the area. So let's find it. It should be in here somewhere. There it is. The area and the circumference. Did I offend anybody today? Everybody's just running out on me. All right, there it is. Write it down. I'll blow it up for you. Write those down. The circumference, or the perimeter of a circle, is equal to 2 pi r. And the area of a circle is equal to pi r squared. And they're right there also. The perimeter, or the circumference, is equal to 2 pi r. And the area is equal to pi r squared. All right, let's take a look at some of the problems that they got in the homework there. One that you might see a good bit of is right here, 24. 24, right here. So look at that one. Let me move it over for you. 24. Said determine, they want to know this area right here of a circle with a 4 centimeter radius and a what? A 3 centimeter radius. So, in other words, you're going to find that shaded region by using subtraction. Find the area of the big circle and subtract the area of the what? The little circle, and you're left with that ring. Because what is a ring? What is a donut? Yeah, but what is a donut? Take the Danish and put a hole in it. What do you have? A donut. All right, what do? You take, what is a ring? You take a whole circle, and what do? You take out the middle, and you've got a ring. That's my son's ring. We bought rings. He wanted to buy, I guess, bonding rings. I don't know what they were, so I had to find 2 rings. One was 11 and a half, and the other one was 5. Now, where do you find a set of rings that are 11 and a half and 5? Walmart. So that's a Walmart special. All right. So what is the area of a circle?
Pi squared.
So pi r squared. So pi is 3.14. R is 4. So if you wanted to set this thing up in one get-go, it would be like this. Pi r squared of the big circle minus pi r squared of the what? Of the little circle. Pi times 4 squared minus pi times what? 3 squared. 16 pi minus 9 pi is what? 7 pi. And 7 pi is your answer. So it'll be around 21 units. So somebody takes 7 and multiply it by pi, what do you get? Use pi 10 digits. Don't use 3.14.
What you don't have?
Then use 3.141597, I think. 265. I rounded through. Sorry. Pi is equal, give me that again.
21.9.
No, give me what pi is. Let's see how close. 3.141592. To what? 654. The only, where I would cut it off is right here. If you just wanted to memorize it, 3.14159. That will give you enough digits to where you can round to the 3rd or 4th digit if you needed to. Now, what was your answer with 7 pi?
21.98.
Okay, 22. So 22 square feet, square inches, square miles. In this case, is square what? Centimeters. And that's how you do that one. This one will make you think. And I'm going to change this one because I'm just going to do a square. Alright? 4 inches, 9 inches, or rectangle. 4 inches, 9 inches. Okay, I'm going to draw I'm going to make this one up. Let's see. There. Below. And here. And here. Okay, there's a rectangle and a circle. I don't like that. fill color. I don't know what the fill color from that would be. Hold on. Okay, don't worry about it. I was gonna try to make a circle that was a different. Okay, we just have to do this. I'll just have to bear with me, okay, till I get this straightened out. There we go. Okay, I'm going to give you, I'm going to say that this up here is 12 feet from here to here. And the radius of this circle is 4 feet. I want you to find the area, and let's see if this will work. I don't know if it'll work or not, but I want to find the area of the green region. Find the area of the green region. Now this is a problem that you cannot do it unless you think a little bit. So those people that can't make change, then you might just have to meditate. Why do you have to think on this one? No, you got the radius. The radius is 4.
Because the shade area is outside the circle.
You subtract the area, you subtract the orange area from the green area. That's why you have to think. What's the side of the rectangle? And the answer, we don't have it. That's not right. Why do you say 8?
Because the radius is 4, the diameter would be 8, and so that's
I'm going to give you a star. That is correct. She got it right. Let me show you a trick I learned in the war. If I take that thing right there and I turn it. It's not turning. Yeah, it'd be nice if something would work one time. I want this to turn. There we go. And I turn this thing. Oops. Sorry. Anybody want to just say I suck? Okay, here we go. You ready? And I turn it to where it's perpendicular, like this. Everybody with me? And as she just said, what is the radius? 2 times, the diameter is equal to what? Diameter is equal to 2 times the radius. Or little r, not big R. So if this is true, then that means D is equal to 2 times 4, which is what? So your diameter, this whole diameter right here, is 8 feet. Therefore, if the diameter is 8 feet, what is the length of this line right here? 8 feet. And that's where you have to think. So now, the area of the green region is what? 8 times what? 12. Minus the area of the orange region, which is pi r squared, which is pi 4 squared. So 8 times 12 is 90 what? 96. Minus 16 pi. And 16 pi is around 48. So you're going to come out with around 48. So 48, 48, 96. So what is 96 minus 16 pi? I'll go over here and sit down and wait. What? I'm asking. I don't know. You know this is 96, and this is a little bit over 48. So 96, 47, somewhere around 47. I don't know. Y'all tell me.
I got somewhere but I didn't know nothing on my calculator.
Okay, well let's do it on the big calculator and see. All right, so everybody agree that 4 times, or whatever I came out with, what, 8 times 12, is that 96? Yeah, Hubert. No, Hubert. Thank you. And 16 times pi, 16 times pi is second there, and I'm going to close that up. I get 45.73. Is that what you got? So your answer is 45.73 square what? 45.73 square feet. So you got a patio that's 12 by 8. And you got a table that's 8 foot across. How many square feet do you have left over? You've got about 45 square feet that you can actually use. How you feel on that one? I feel good. Oh yeah, I forgot this is the wrong class. This class don't feel good. There was one I wanted to go into, and that was the problem that I pulled up a while ago. I do want to go over it, another puzzle type problem. And it's in 9.2, I believe. Well, I just got out of it. Dang it. There we go. It's the one with the angles. And I pulled it up a while ago and I said we're going to go through that one. I just got to find it again. That's this one right here. The first thing I would do if I was you is draw a bigger rendition of it. And make the triangle in the middle smaller. That's what I would do. Like that. That's the first thing I would do when you do this problem. Got another one right here. Okay, we don't have any problem with these too much, but what's the problem down here? What's the problem in the lower right-hand corner down here? What's the problem here? They don't give us anything, Hubert. That's right. They don't give us anything down here. So that means we've got to work diligently to find something over here, or we can remember our formula that says 180 times n minus 2. That will give us our interior angles. How many sides does a triangle have? So that's 180 times 3 minus 2, which is 180 times 1, which is what? So how many interior degrees does a triangle have?
180.
What do we have here and here? We got 2 out of 180, so 180 minus 64 minus 59 is going to be what? 77 or 67 or 57? What is it? 57 degrees. So angle 7 is 57 degrees. Now you can fill in pretty much everything. Somebody tell me what angle 2 is. What's angle 2? 59 degrees, Hubert. That's right. Why?
Vertical to the other.
Vertical. What's angle 12?
57.
What's angle 9?
54.
All right, now find angle 3, or angle 5, or angle 8, or angle whatever you want to. Angle 8 is easy to find. What's angle 8? What? I didn't hear you.
11. Is that number 11?
Yeah, that's number 11. What's that angle right there? Well, it will be angle 11 whenever you find this one. 123. Yes or no? Why?
Yes, because
Because 180 minus 57.
This is 180 minus 57. So angle 11 is 123. All right, you ready for this one? You know what this angle is? $57. Alternate what? Alternate interior angles. This angle is the same as this angle because these lines are what? Parallel. Now somebody tell me what angle 3 is. Well, 60 plus 57, that's 100 and what? 100 and, I can't add those too well. So 117, 116. What's 116 from 180?
64.
So that's 64, and that's 64. And then 64 from 180 is what? 116? Huh? I can't, I'm asking y'all.
116, yeah.
So that's 116 here, and 116 here, and you're done. So this is just like a big what? Big puzzle. You put the pieces together. Continue working. Hopefully y'all get through soon. Let's go ahead and check on the attendance.